welcome everyone. Good to see everyone in our office. We're going to be talking about practical security guardrails for LLMs. For those that aren't aware of Sneak, our name is an acronym, so now you know, and we build developer-first security products and ASPM software. We very recently added DAST into our product portfolio as well. Some background on me. I am not an AI expert or founded my own AI startup. So if you have any detailed LLM questions, I will happily take them and relay them to some of my colleagues here, and hopefully other people can answer that. I lead our product security function at Sneak. I have done for the last 2.5 years, and my background is, before going into security purely in 2017, was as a Linux sysadmin and doing networking and cloud and everything in the DevOps space for the 7 years previous to that. So here's a bit of structure of the talk. So we're going to have a look at glossary for some of the terms and just setting some expectations. Then we're going to look at how I've structured this is into the threats and the practical guardrails or the security controls is based around 2 main use cases. As you can see there, it's those companies or users consuming LLMs, primarily SaaS products, and those that are building LLMs into their products. Then got a link at the side at the end, which just covers some useful resources, which I actually use to put the content together for these slides. First up, glossary. And apologies, I don't know if you can see, if anyone's struggling to see the text. Didn't bear in mind the potential screen size. But when I refer to AI, what I mean is LLMs. There are other areas of AI, but that's what we're going to be talking about in the context of LLMs. RAG, retrieval augmented generation, it's essentially a fancy term for looking up data from external sources beyond what's trained in the model to use as context. And then SFT, supervised fine-tuning. This is really when we're just fine-tuning the LLM with desired answers. An example of that would be getting security experts to label good quality code snippets for fixing security vulnerabilities. Bit of a foreword before we go into specific sort of new threats and LLM specific security controls is that your existing DevSecOps practices, security engineering practices still apply. It's just the new technologies, new systems, new data flows, new contexts. If you're introducing these systems, you still need to be making sure you're identifying them, tracking them, tagging them in your asset inventory systems, getting some intelligence, some asset classification around them, carrying out threat modeling, identifying what your system-specific requirements are and what the specific security requirements and controls are to protect against any new threats there. Similarly, introducing, security testing, doing all your platform hardening on the environment where they're residing in, making sure you're doing all the good stuff like regular updates, and if you've got good protective monitoring and incident response process in place. The last bullet point here is emboldened and underlined because of to emphasize the importance on the quality of life for your security teams by doing this. So it's fair enough to go all over the place, prototyping solutions in sort of sandbox dev test environments. But when you're introducing new LLM-based tools into your companies, into your production environments, please keep them as simple as possible and as standardized as possible. So your security teams only need to make sure they're providing security guardrails for one or a handful of implementations as opposed to tens or more. Cool, so let's dive into the bulk of the talk. So here's the 2 use cases that we've grouped around. We're going to group the controls and threats around. So for those companies or users which are just consuming LLM-based tools, the context here is predominantly AI code assistance. We've got sensitive information disclosure and vulnerabilities in the AI-generated code being introduced as new threats. Taking a look at the first one, we need to be careful about what information is being passed into the models or what data is accessible by RAG lookup, because LLMs may disclose sensitive information to users that weren't intended to have access, either inadvertently or through prompt injection. Some recent examples of this are, if anyone saw the news articles about Copilot happily providing free API keys to anyone who was requesting it, because developers had been inadvertently putting it in their prompt input. Another sort of simple theoretical example is an HR department deploying an internal chatbot and putting all their company's financial data in there, inadvertently exposing employees' salaries to anyone who's got access to query it. A real-world example here was back in early 2023. News article came out that Samsung employees had accidentally leaked sensitive source code via ChatGPT. In one instance, an employee posted confidential source code to check for errors. A second shared code with ChatGPT requesting code optimization. And a third shared a recording of a meeting to convert into notes for presentation. I think all common use cases that everyone's probably considered or has used LLMs for, but it's just something to bear in mind in terms of using SaaS products and how they use your data to train their models. What protections can we put in place for this? So the first thing is have a data model, understand what types of data are involved, the sensitivity of the data that's being shared. Is it appropriate to share that data with third parties? Is the vendor able to protect that data? The second one is not particularly glamorous, but making sure you've got defined policies, standards and procedures, and having user training and awareness of what users or engineers should be doing, and they know to use that as a reference when they're using those tools. A more concrete control is ensuring you've got contractual terms that govern how your data is being processed with the vendors, making sure that it's not being used to train their models, and practical things you can put in place are what are being referred to as LLM firewalls or shields. Essentially, these operate in between the user and the prompt, and they're filtering input. An example could be your security team has put one of these firewalls in place and has configured it to identify and filter out any credit card information that any of your users may be trying to put into that prompt. This can be used for output validation as well. So this can also be used when you're building LLMs into your products. There's quite a few. It's a sort of new implementation of input validation and filtering, and there's as a new sort of thing. There's lots of new vendors in that space. A few examples that we've come across on Nightfall AI, Cloudflare, and Arthur AI. But yeah, it's worth doing your normal vendor evaluation to figure out what works for you. The second one for this use case is vulnerabilities in the code being generated by your LLMs. Significant increase in code volume as developers are using AI code assistant to generate the code, but most importantly, it's code that developers creating it are less familiar with. A recent study by Georgetown University found that 80% of the code snippets they generated by using 5 popular LLMs contain security vulnerabilities. Security is not the only problem here. It's a general quality issue. A study by CircleCI found that there's lower success rates and longer recovery times for AI-generated code. I think longer term, this should be a problem that can be solved by supervised fine-tuning, including the feedback mechanisms. But for the time being, it remains a problem that we need to address. Looking at what protections are available, I think the first thing and simplest thing is optimizing your existing automated testing and SaaS remediation activities. If your teams are overwhelmed with SaaS vuln management before using AI code assistants, the problem's only going to get worse. So I'd say refine the implementation of your DevSecOps principles. Examples being, shared responsibility, making sure all developers are responsible for security, and align goals. So your project managers or product owners aren't deprioritizing security work and it's actually getting addressed. Also, if you're having problems with your tooling, if you're suffering with false positives and needs excessive tuning, use a better tool. We can also look at new developments in the security testing space, leveraging AI to make our lives easier. So using LLMs to help solve problems that LLMs introducing. This is sort of the one and only Snyk product plug I'll give during this. But Snyk's DeepCode AI SaaS tool uses our own in-house fine-tuned models to help identify vulnerabilities more accurately. And we also have an AI auto-fix capability which generates automated fixes, sort of reducing the burden and workload of developers and security engineers to do that themselves. Cool. So now into the use case when you're building LLMs into products. They are more new threats than this, but these I think are the most interesting. So let's take a look at these. So we've got data and model poisoning and prompt injection. We're also covering excessive agency in this, but excessive agency is essentially just an authorization problem, and it's predominantly exploited via prompt injection, so we're covering it at the same time. So the data used by LLMs is crucial as it forms a foundation on which the models learn patterns and make predictions. The deliberate manipulation or corruption of the data used introduces inaccuracies, biases, or vulnerabilities. That could be as simple as bias and censorship, and recent examples of that are, if you asking DeepSeek about Tiananmen Square or Taiwan, or ChatGPT's sort of weird refusal to acknowledge the existence of David Meyer, which was apparently down to a bug, but yeah. Or it could manifest as more convoluted backdoors, or even harmful code executing when the model is loaded. There's greater risks here with the widespread distribution of models on platforms like Hugging Face, often with little or no accompanying security assurance information. There's a real-world example of this. So in July 23, researchers modified an open source model to spread misinformation and uploaded it to Hugging Face. It managed to evade detection by a benchmark tool called ToxicGen2. It was an educational exercise, but highlights the risk. So what can we do to protect against data and model poisoning? So the first thing is use diverse data sets. Don't rely on a single data source unless you are absolutely sure about its trustworthiness. Audit the sources and assure they're from reputable sources. So ensuring data sets are from trusted sources. So an example of a trusted source could be a research institution releasing data set alongside a white paper or article describing how it was collated. Be careful when scraping the web for content. Think about weighting towards more trusted sources. OWASP's SBOM tool, CycloDX, also has machine learning bill of materials, ML-BOM, capability, which provides visibility into the provenance of data sets, training methodologies, and the configuration of AI frameworks. So that would just be useful just to get a better understanding of what's under the hood of the models you're looking to use. And also anomaly detection and model testing tools. This is a space where we're seeing lots of new companies coming up and lots of new tools testing models for vulnerabilities. So yeah, it's worth evaluating those. Prompt injection. Prompt injection is when malicious input causes the LLMs to execute unintended actions. This can be intentional or unintentional, and there are two types. Direct injection, which as the name suggests, involves direct user input into the prompt. Indirect injection involves input from secondary external sources, which may not involve user interaction. The impact of prompt injection can be wide-ranging, but we're based on what data and downstream systems the LLM has access to. Examples can be information disclosure, privilege escalation, and even code execution. Some real-world examples. So for direct prompt injection, in November 24, a hacker used direct prompt injection to override the prompt restrictions and win $47,000 in a cryptography hacking competition. The competition revolved around an Ethereum wallet controlled by Fraser AI, an AI agent program with a singular directive: never transfer funds. Participants were tasked with crafting messages to convince the AI to release the wallet's content. After each attempt required a fee, with increasing with every subsequent message, creating a growing prize pool. Here's the actual winning prompt. I've read it 3 times and I can't follow what's going on with it, so I wrote something down to explain what's happening. So the participant exploited multiple vulnerabilities simultaneously by initiating a new session, effectively resetting the AI's prior instructions. They then redefined the AI's approved transfer function, framing the transaction as compliant with its directive to never transfer funds. Here we've got an example of indirect prompt injection. This was in September 23 and impacted Google Bard, which has now been renamed to Gemini. A vulnerability was discovered for indirect prompt injection via its extensions functionality, which allowed Gemini Bard to analyze untrusted data via Google Docs, Drive files, Gmail emails, and YouTube videos. The problem here being that you could force prompt injection by sending emails and sharing docs with users without their consent or interaction. Here's a better description of the vulnerability. It's introduced by Bard trying to be helpful by summarizing the content it's being provided. In this case, it was a Google Doc rendering an image, which resulted in exfiltrating the user's previous chat session. So protections against prompt injection. Use predefined prompts which govern the expected behavior. Enforce access control on backend systems. This is the protection against excessive agency, which is a risk in its own right in the OWASP LLM top 10. But it's often exploited via prompt injection attacks, and the protection is essentially least privilege. Only connect your LLMs to the systems that you intend to be accessed. Use RBAC and configure the roles with least privilege permissions to make sure it's only able to execute intended functionality. Implement input and output validation and filtering. This is what we discussed in the first use case for filtering protection against sensitive information disclosure. So it's leveraging those same LLM firewalls to filter the prompt input and output. Implement a human in the loop as an approval process for anything which is particularly sensitive, and make sure you've got protective monitoring in place, because you're not going to catch everything with your protections. So this is so ensure that your security team is able to take a look at anything which looks suspicious. Cool. We got to the resources section. Just give a brief description of these. So top one is the OWASP top 10 for LLMs. This has recently been updated for 2025, and is a really useful reference document. Just below that, we've got Snyk Learn, which is another sort of Snyk plug. It's completely free, and it's a great training course on which surrounds the LLM top 10 with real examples and a quiz. So yeah, it's definitely worth checking out. Below that, we've got the CISA and NCSC guides. These are pretty dry, but they're very comprehensive and useful as a reference for when you're looking to build these systems, because it covers all bases. Next one, we've got the OWASP LLM and generative AI security solutions landscape. This maps security tools to different stages of the SDLC and also to the top 10 risks. So this is a useful reference document showing you which tools can protect you against these particular threats. And the final one is just an article on red teaming. It's important to carry out security testing to identify if your systems are vulnerable and that the security controls you put in place are effective. So this is a useful resource describing a good approach to how you go about doing that. So finally, just a call out to DevSecCon, which is the community set up with Sneak. We do quarterly events. There is a Discord server. And yeah, if you want to have any more information about that, then free to follow those links, or you can come and ask me about it and I'm happy to talk you through it. So, thanks all.